Hi, my name is John Krockmalling, and I've created this tutorial as an instruction for anyone wanting to learn how to configure a digital multimeter and take measurements. It is very important to understand that electrical energy can be fatal or cause serious injuries. This being said, do not touch exposed live electrical circuits and related components. Always handle the multimeter and related leads by their plastic non-conductive frames and not by the metallic portions. When working on live and exposed electrical circuits and components, always wear the correct personal protection equipment specified for that particular job, as outlined by the National Fire Protection Association NFPA 70E standard for electrical safety in the workplace. There will be two learning outcomes related to this presentation. Number one, configure digital multimeters to measure voltage and resistance. And number two, read digital multimeter electric values. With digital multimeters, there is no needle indicator. The values are read in a digital format, and there is no parallax to consider. Since there is no needle position to observe, the displayed value provides for the precise numerical value of the measurement. The displayed value will always have a numerical reference. As with analog meters, the perspective of the viewer can cause an error when reporting the displayed value. This is called parallax and is associated with the different angles of perception and its related scale values. With digital multimeters, parallax is not a problem. The displayed value is the value of the measurement. Configuring the digital multimeter involves 5 steps. Number one, consider what it is to be measured. Number two, set the multimeter leads. Number three, set the multimeter selector switch. Number four, set the multimeter range. And then number five, take the measurement. Let's start out by configuring the digital multimeter to measure voltage. Since we already know what it is we want to measure, in this case voltage, the step involves setting the leads of the multimeter. The black lead is always placed into the COM or common black port of the meter. The red lead will be placed into the meter port marked as red and may have either the letter V or a positive plus identification. Step 3 involves moving the selector switch of the meter to read voltage pressure. On these two graphics, we see the position marked with a V for voltage, but there are two positions for this measurement. Notice associated with the letter V are two symbols. Alternating current voltage is the symbol with a sine wave. Voltage measurements could also include direct current, which has its symbol as a solid line drawn above a dashed line. Step 4 involves the range of the measured value expected. Notice on the Fluke meter on the right, one could only measure up to and including 99.99 of something. Pressing the range button once will move the displayed decimal point over one position and therefore accommodating a larger number. The fifth and last step of configuring a digital multimeter involves taking the actual measurement. Keep in mind that in many digital multimeters, it may be necessary to select which voltage one is trying to measure, whether it is direct current or alternating current voltage. Keep in mind that digital multimeters can measure either voltage applied to the circuit or the voltage dropped across the circuit load. When measuring voltage with a multimeter, the leads are placed in parallel to the devices being measured. Again, configuring the multimeter involves the 5 steps. Number 1, consider what it is to be measured. Number 2, set the multimeter leads. Number 3, set the multimeter selector switch. Number 4, set the multimeter range. And then number 5, take the measurement. Let's start out by configuring the digital multimeter to measure resistance. Since we already know what it is we want to measure, the steps involved setting the leads of the multimeter. The black lead is always placed into the COM or common black port of the meter. The red lead will be placed into the meter port marked as a red and may have either the letter R, omega, or a positive plus identification. Step 3 involves moving the selector switch of the meter to read resistance. On these two graphics, we can see the position marked with an omega for resistance, but it also could be marked with an R. Step 4 involves the range of the expected measurement. The displayed values will also have letters to show that those values are going to be, according to scientific notation. The capital letter shown here is a capital M, which stands for million. Whatever numerical value is displayed, it is going to be intended to be in millions. Other letters displayed could be a capital K for thousands. Quality digital multimeters will also have a function called auto range, which does not necessarily need the user to set the meter ranges. The auto range function of the meter does this automatically. Step 5 involves taking the actual resistance measurement. The OL displayed stands for open line and is what one can expect the measurement to be if a fuse or conductor does not pass current. For those of us having experience with analog multimeters, zeroing out multimeters to read resistance involves moving the adjustment wheel. Digital multimeters configured to read resistance does not have this wheel function. However, one could test the multimeter function for operability by placing the two leads together. If the displayed value moves from OL to very low resistance, the meter is functioning properly. Also, a major consideration is when taking resistance measurements with a multimeter, the power has to be removed from that device before measurement. Here in this graphic, we see the R1 load removed from the circuit's power and the resistance configured meter applied. To review this presentation, digital multimeters have no needle actuator. They read in digital format and there is no parallax for consideration. And using digital multimeters involves 5 steps. Number 1, consider what it is to be measured. Number 2, set the multimeter leads. Number 3, set the multimeter selector switch. Number 4, set the multimeter range. And then number 5, take the actual measurement.